Okay, simplifying algebraic expressions. Now what you need to see is that the numerator here is an algebraic expression, and so is the denominator, okay? And we're dividing them, all right? So it's a fraction, right? So that's why we call it a rational sort of expression here, because rational, if you think about a rational number, it can be like a whole number or a fraction. That's what a rational number is considered as. Any number written as a fraction is rational. And here we've got a rational expression, okay, and we're asked to simplify it, all right. In some cases we'll get rid of the fraction, okay, if we're able to. So let's look at the first case here. Now what I need you to see is, right, first of all, you see all of this divided by x, okay, but what you need to appreciate is each individual term actually needs to be divided by x, okay. The whole lot needs to be divided by x, but we can think of it as each individual term divided by x. So we'll split it up, okay, and we'll write individual fractions, okay. So 3 fractions I'll need, because there's 3 terms on the top. So we've got 7x to the power 4 over x, take away, okay, because there's a minus there, 2x cubed divided by x, and then you've got a plus 6x divided by x, okay. So when you're dividing a collection or a summation of terms in the numerator here by x, for instance, you can split it up and divide each individual term by x. And it's important to do that. Every term needs to be divided by x, not just one of them. Okay, you gotta think about every one of them. Every one of them needs to be divided by x. So by splitting it up, we can actually do a bit of algebra here, okay? Rules of indices. It's really simple, isn't it? Because that's like x to the power 4, and that's like x to the power 1. So when you're dividing, do you remember when you're dividing rules of indices, you take away the power, don't you? So 4, take away this one, which is 1. So 4 take away 1 is 3. So this becomes 7x to the power 3, okay? Taking away the powers. Same here. Now let's write that minus first. That's the power 1, yeah? So 3 take away 1 is 2. So it'll be 2x to the power 2. And then finally then we've got a plus, okay? Now here, if you think about it, the x's will cancel out, won't they? Okay? Because you've got x divided by x, which is 1, all right? Or you can see the powers, can't you? 1 there, and the power 1 there. 1 take away 1 is 0, and x to the power 0 is just 1, yeah? Anything to the power 0 is 1. So, you know, I just see it as the x's cancel because they divide, so you just end up then with plus 6, okay? So there is your simplified expression. It looks a lot nicer than that, yeah? By splitting up the terms. Let's look at another one, okay? So in this case here, you can see we need to divide every term on the top by 2x, so let's split it up, right? So we'll have 3 fractions then, 8x to the power 4 divided by 2x, take away then, because there's a minus there, 4x cubed over 2x, and then there's a plus then, 6x divided by 2x. So in this case there, we not only just the x's we're concentrating on, but we've got numbers here as well. So 8 divided by 2, of course, is 4. And then when you take away the powers there, you end up with x cubed minus 4 divided by 2 is 2. And then x cubed divided by x is x squared. And at the end then, well, again, the x is cancelled, isn't it? And I just got 3 there. 6 divided by 2 is 3. So there's my simplified expression, all right? So then let's look at this one, right? So we've got 4 terms this time. So that means when we split it up, we're going to have 4 individual fractions, okay? And we want to divide each of those fractions by negative 2x, okay? So I can write these on the bottom here, okay? And then on the top, well, let's see what we've got. To start with, we've got negative x to the power 8. Then it's plus 9x to the power 4. Then it's minus then, okay, so we've got a minus there as well, 4x cubed, and at the end then we've got plus 6 over there. So you've got to be a bit more careful now when it comes to dividing these, okay, because this, you know, we're going to have fractions, I think, because it's not so nice. But here, notice with the first term, minus divided by minus becomes a positive, doesn't it? Okay, so the minuses just cancel each other out, positive. The x there to the power 8 divided by x, well, that'll be 8 take away 1, so it'll be x to the power 7. But there's no number here, it's just 1, isn't it? And we've got 2 on the bottom. So that'll leave us with a fraction of a half, won't it? So I can write that down if you wanted to start with. Yeah, because I've got 1 here and 2 there, so that's a half. And then x to the power 7. Alright, so we end up with a fraction term there. We're going to end up with a fraction term here as well, aren't we? Because 9 divided by 2 is 4.5, isn't it? But we don't want to write 4.5. We don't want to have decimals. We leave it as a fraction, so 9 over 2. But there is a minus here, and there's a plus there. Plus and the minus become a minus. Okay, so we end up with that 9 over 2x cubed. Next then, well, look here, let's look at the signs. 2 minuses, yeah, minus, and then a minus here, it becomes a plus. And 4 divided by 2 is 2, so that's quite nice. And x squared that will become, yeah. And then finally then, we've got plus and a minus becomes a minus. 6 divided by 2 is 3. Okay, so you can do that. But there's an x on the bottom, there's no x on the top. So we just leave it there on the bottom, right? You could take it up, I suppose, and put it to the power minus 1, but I think it looks nicer to leave it like that.